love the red. Here we go. Today we're going to do 3, 3, and 3, 4, and I'd like to go 3, 5. We'll see. 3 by 3 linear systems. A linear system is 3 equations and 3 unknowns. Therefore, 3 rows, 3 columns, thus the name 3 by 3. AXPY plus CZ equals J, DX plus EY plus FC is K, GX plus HY plus IZ is L, where all the A, B, C, D, F, H, and J, K, L are constants, and X, Y, and Z are the values trying to be found. And we check a solution by substituting the values of X, Y, and Z and see if all 3 of these equations are valid. Now, from previous section, I talked about row operations. So if you have an equation, then you rescale it by multiplying both sides by the same amount. And you can combine 2 rows, adding K times 1 equation to the other equation. So A equals B and C equals D means that A plus KC equals B plus KD. This is rescaling, this is combining. And solution by elimination is to use row operations to eliminate variables, just like with the 2 by 2 system. All right, so for example, we'll check these 2 solutions of these 2 systems. Does 2, 1, 1 solve X minus Y plus Z equals 2, 2X plus Y minus Z equals 4, and 2X minus 3Y plus Z equals 2? All right, it's easy enough to check. Put 2, 1, 1 in for this equation. We get 2 minus 1 plus 1. That does indeed equal 2, so yes. Plug in 2, 1, 1 here. 2 times 2 plus 1 minus 1 plus 1 minus 1 is 4, so this y equation checks. And plug in 2, 1, 1 into this. 2 times 2 minus 3 times 1 plus 1. That's 4 minus 3 plus 1, which is 2, and check, yes. So all 3 equations are valid with these values of X, Y, and Z. So yes, this triple does solve this equation. Here's another one. Does 6, negative 7, negative 5 solve 3x minus 2y minus z equals 37, x minus 3y equals 27, and 2x plus 7y plus 2z equals negative 48? All right, here we go. We substitute 6, negative 7, and 5 for x, y, and z. The first one becomes 3 times 6 minus 2 times negative 7 minus a negative 5. That's 18 plus 14 plus 15, which is indeed 37. So the first equation does check out. The second equation, x minus 3y equals 27. We have 6 minus 3 times negative 7. That's 6 plus 21, which is indeed 27. So the second equation checks out. Now, here, put 6, negative 7, negative 5 into the third equation. 2 times 6 plus 7 times negative 7 plus 2 times negative 5, that's 12, minus 49, plus that's a 10, or minus a 10, excuse me. That comes up to a negative 47, which is not 48. So third equation, not valid with this value. So this does not solve that equation. It solves 2/3 of them, but not the whole thing. And 2/3 isn't good enough. All right, now, so we'll use the solution of by elimination to solve this system. X plus y plus z equals 4, 2x plus y minus z equals 1, and 2x minus 3y plus z equals 1. The idea is we're going to pivot on this x because it's a 1x, and we want to clear away these 2 x's here, the 2x and the 2x here. So we'll clear this column, leaving only this x, and eliminating these by using row operations. We have 2x here, so if we subtract twice this x, that should cancel it. We have 2x here, so if we subtract twice that x, it should cancel it. So here we go. The first equation is untouched, x plus y plus z equals 4. This one will subtract twice equation 1. 2x minus twice x is a 0. Y minus twice y is a negative y, so that's what we put here. Z minus twice z is a negative 3z, so that's what we put here. And 1 minus twice 4 is a negative 7, so that's what goes here. So the second equation gets changed to negative y minus 3z equals negative 7. The third equation, we'll subtract twice equation 1 from it. 2x minus 2x is a 0, cancels. Minus 3y minus twice y is negative 5y. So we put a negative 5y here. Z minus twice z is a negative z, so that goes there. And 1 minus twice 4 is a negative 7, so it goes there. So we have x plus y plus z equals 4, negative y minus 3z equals negative 7, negative 5y minus z equals negative 7. Now, okay, a bunch of negatives around here. There, I find them annoying, so let's rescale these, both of these equations by multiplying by negative 1. So you get y plus 3z is 7, 5y plus z is 7, x plus y plus z equals 4. Okay, now I'm going to pivot on this y. In other words, I'll use row operations to eliminate the y in the first equation and the 5y in the third equation. Now, okay, y minus y should cancel here. This 5y minus 5 of this y should cancel there. So we'll take the first row in the equation and subtract the second equation. All right, so x minus nothing is still x, so there's x. Y minus y is 0, so y is zeroed out. Z minus 3z, that's negative 2z, so we put a negative 2z here. And finally, 4 minus 7 is a negative 3, so put a negative 3 here. So we get x minus 2z is negative 3. This equation will just keep the same. This equation will subtract 5 of the second equation. So 5y minus 5y cancels. It's gone. Z minus 5 times 3z, or that's a positive. Z minus 5 times 3z is a 14z. Just a second, let me fix that. Excuse me for a second, I make a note here to change the notes. This is 3, page 3. All right. And where was I? Sorry. I'm saying negative 14z. Okay, here. That's what happened. Okay. And then 7 minus 5 times 7. 7 minus 5 times 7 is a negative 28. So negative 28 goes here. Now here, the last equation is turned into negative 14z minus equals negative 28. So we'll divide both sides by negative 14 and get z equals 2. Now, I'll pivot on this z, basically eliminate this 3z and this minus 2z. We'll subtract 3 times equation 3 from equation 2, add twice equation 3 to equation 1. So here we go. Here, x plus nothing is an x. So what? Negative 2z plus 3 times z plus twice z is 0, so no z, and then negative 3 plus 3 times 2. Negative 3 plus, 2 times 2 is a 1. You get a 1 here. For the second equation, y minus 3 times nothing is still y. 3z minus 3z is 0. It's eliminated. And 7 minus 3 times 2 is a 1. So you get, reduces down to x equals 1, y equals 1, and z equals 2. And you can easily check to see if by substitution to see if this works. I gotta say, these 3x3 systems, we solve them the same way we solve the 2x2 systems, but they're they're more than twice as big, so they take almost twice as long, which is annoying. Here we have a system. 7a plus 9b minus 2c equals negative 5. 5a plus 14 minus c equals negative 11. 5a minus 5b, 2a minus 5b minus c equals 3. Okay, first I rescale this by a negative 1 and thus turn this minus c into a plus c. So minus 2a plus 5b plus c equals negative 3. Now we can pivot on this, eliminate these c's here by adding twice equation 3 to equation 1. And adding equation 3 to equation 2. And after a bunch of the same arithmetic as before, we get something like this. 3a plus 19b equals negative 11. 3a plus 19b equals negative 4. And then as before, minus 2a plus 5b plus c equals negative 3. And I think you can see that we're heading into trouble because 3a plus 19b It's trying to be both -11 and -14, and that won't do. If we subtract equation 2 from equation 1, now the 3a's cancel, the 19b's cancel, -11 minus -14 is 3, and we get the equation 0 equals 3. What in the world? Okay, that's absurd, but that means the original system was absurd. This can't happen, so this can't happen either, and therefore this original system has no solution. That's in general the case. If you get, there's no solution if after all the row operations you get non-zero equals 0. So this is a case of when it's, and maybe these 3x3 systems are basically planes in space, and maybe the planes are parallel to each other, or maybe they form a cylinder, or one way or the other they don't ever work out. So let's see. 335 asks, now okay, here we have a system where first we do some transposing to get them in the right form, and then we do some some rescaling for here, and we do some row operations here, and look at this. Look at this. This and this were the same. These in fact were identical equations, so when you subtract equation 3 from equation 1, you get 0 equals 0. Well, here you wind up with basically only 2 equations worth of information for 3 variables, and that's not enough. So therefore, there are many solutions. It's underdetermined. There's not enough equations worth of information to cover the 3 values. So if you ever get 0 equals 0, the result is underdetermined, or in other words, there are many solutions. There's insufficient information for a complete answer. Is that it? Okay, fine. We'll stop the robot.